Welcome back, Wolfpack, and welcome to the second part of 1.8 angle pairs. If you have not already watched 1.8 angle pairs part 1, you need to go ahead and do that before you do the second part. We learned in the first part of our video the different types of angle pairs and whether they are congruent to each other or supplementary. And so today we're going to expand on that a little bit more. So, a converse is a statement that switches the hypothesis and a conclusion of a conditional statement. You might have heard about converses maybe in your science class, but an example of that is, if an angle is 90 degrees, then it is a right angle. Well, the opposite is also true, that if an angle is a right angle, then it measures 90 degrees. So we switch the order. So today we're going to talk about the converse of the theorems that we learned last class. We learned last class that if two lines are cut by a transversal, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Well, the converse of that is, if two lines are cut by a transversal and it results in the corresponding angles being congruent, then we can say, oh, those lines must be parallel. The converse of the alternate interior angles theorem says, if two lines are cut by a transversal so that the alternate interior angles are congruent, then also those lines must be parallel. So this is basically telling us that if I have two lines and they're cut by a transversal and my angles end up being congruent or supplementary, then that tells me, oh, those lines are parallel to each other. The alternate exterior angles theorem says, the converse of the alternate exterior angles theorem says, if two lines are cut by a transversal so that the alternate exterior angles are congruent, then again, those lines are parallel. And the last theorem says, if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. And I told you last video that you might see consecutive interior instead of same side interior. So they might use the word same side, they might use the word consecutive. So if I'm looking at a picture and I see that I have angles that are congruent, depending on what the relationship is, that might mean that the lines are then parallel. So here's an example. Is it possible to prove that the lines are parallel? If so, state the theorem that you would use. Well, they gave us two angles. Okay? Those two angles are same side interior. They're on the right side of the transversal. They're between the two lines. I know that if same side interior lines are supplementary, then that means the two lines are parallel. So 78 plus 102, they add up to 180 degrees. Are those supplementary? Yes, they are. So since those two angles are supplementary, these lines are parallel. So I would say yes. And the reason I'm allowed to say this is because of the converse of same side interior, I'm going to abbreviate it, angles. Let's look at example B. They gave us two angles. They marked that these two angles are congruent. This mark and this mark, they both have one mark. That means that they're congruent to each other. Well, I know those two angles are vertical, and I do know that vertical angles are congruent. But vertical angles are always congruent. That does not make lines parallel. So the answer to this one would be no. We do not have enough information to prove that these lines are parallel just because we have a pair of vertical angles. Example 4. Find the value of x that makes m parallel to n. Well, this angle and this angle are corresponding angles. Okay, they're both in the upper right-hand side. I look at this set of angles, 71 is in the upper right-hand side. This set of angles, 2x plus 3 is in the upper right-hand side. They're corresponding angles, and in order for m to be parallel to n, these two angles would have to be congruent to each other. So we have to figure out what x would have to be in order for them to be congruent to each other. So I'm going to set them up. 71 equals 2x plus 3. So I'm going to pretend that they're congruent to each other to figure out what x would have to be. So we subtract 3 from both sides, divide 2, and we get x equals 34. So if x was 34, that would make the two angles congruent to each other. And if they were congruent to each other, that would mean that the lines would be parallel because those two angles are corresponding angles. So today's brief lesson was basically the opposite of what we learned last class. Last class we learned that if the lines were parallel, then the angles are either congruent or supplementary. This lesson was, if the angles are congruent or supplementary, then we're allowed to say the lines are parallel. Okay, it's the opposite or the converse of that. Okay, we'll do lots of practice with finding angle measures and so on, but those four pairs of angles, you're going to definitely need to know those. You're going to need to know whether they're corresponding, same side, alternate interior, or alternate exterior. So be prepared to practice those a lot. Hope you have a great day, Wolfpack, and I will see you next class.